Yeah, because we started looking at the basic graphs for sine and cosine. And we did amplitude last time, is that right? Okay. So we were looking at that period of the sine and cosine functions. We looked at example 3. So let's look at exercise number 3 here. Okay, so looking at this example, what is the amplitude for this given function? Oh, you don't have that? Yeah. So, come on. Okay, so let's see. All right, let's review our information here quickly before we get into example 3. So when we're talking about amplitude for a function, remember we're talking about that constant that's being multiplied into your function value. So in this case, when we have y equals a times sine of x, y equals a times cosine of x, it's that a value that we're calling the amplitude. And of course, amplitude is going to be the absolute value, right? So if it's positive or negative, the amplitude will just be the positive value. So we had looked at these examples when you had 1/2 cosine of x and 3 times cosine of x, and you can see how that changes the graph for our function. So if you look at the gray image, that's your basic cosine value, and then with the 1/2, you can see we went from the 1 amplitude on the cosine function to 1/2. So of course, that's those heights of your peaks and valleys is going to go down, right? But when we're talking about 3 times cosine, of course, that increases that height on your waves, your functions. The next thing we are looking at is the period of the sine and cosine function. So if you have this constant value of b, and that's going to be in the form of sine of bx, cosine of bx, right? So it's the b variable that gets multiplied by this positive real number. And that's actually going to reflect on what the period of those functions is going to be, because now you can see we take the period of 2 pi, which is what our cosine and sine functions have as their period, right? And then you divide it by the value of b. So the idea is if the b value is going to be greater than 1, you are going to see a horizontal shrink. If the b value is going to be between 0 and 1, you're actually going to see a horizontal stretch. And we had looked at this example, y equals sine of x over 2. So x over 2, that's the coordinate on the x variable, which is actually going to be 1/2. So that becomes your b value of 1/2. When I divide my 2 pi by 1/2, it actually increases the period for this function, and it ends up becoming 4 pi. And then, of course, when you look at the graph, look at how far that period basically doubles, right? Because now, again, the gray function is your original sine function, and then sine of x over 2, you can see that horizontal stretch happening on the sine of x over 2. the b value is 1/2, but the period is actually 4 pi.
Okay.
So the
Oh,
b,
is that just
right, because the b will calculate with your period. And so it's going to change anytime you have a b value, which is basically anything other than 1. So in this case, yeah, and then I think we talked about this briefly last time. So in this remark, they are saying that you will take your period interval. So let's say that was 4 pi in the previous example, and you end up dividing your period by 4. And when you divide your period by 4, it actually gives you what the intervals will be when you're trying to graph your function. So in this case, you start with your left-hand point, which will be negative pi over 6, and then keep adding whatever this calculation of period divided by 4 comes out to be, and then you will get your basically 5 different points that, remember, we need to graph our functions here. So we're looking at number 3, y equals cosine of x over 3. So the first thing you should notice is that we have no coefficient in front of the cosine, right? Which means your amplitude is going to be what number? That a value. The a actually is just going to be 1, because remember, your basic form of the function that we are looking at, right? So when you're talking about this a value, if there's no number in front of cosine, that a value is understood to be 1. So your amplitude in this case is absolute value of a, which is going to be 1. And then 1/3 will be what then? The b value. Very good. So remember, the b is the coefficient on the x term, and in this case, if you can rewrite, you want to rewrite that function, you can write it as cosine of 1/3 x if it helps you out that way. That means your b value is going to be 1/3, and if b value is going to be 1/3, then how does the period of our function change? So remember, period for a basic cosine function is 2 pi, so you take 2 pi divide by b, or 2 pi divided by 1/3 will end up giving you what? Yeah, you're actually going to end up with 6 pi. So again, if your period is changing to 6 pi, that means we're going to see a horizontal stretch in our cosine function here. Okay, so if your period is 6 pi, that means your period interval is going to be starting at 0 and going to 6 pi. Okay. So remember, in that remark we looked at, basically to come up with our 5 key points, we need to take that period interval and break it up into 4 equal parts. So the first thing you actually want to start out with is taking the difference between your two values, which in this case is 6 pi and 0, right? The difference between the two values will just be 6 pi. And then take your 6 pi divided by 4, and what do you end up getting? Okay, so to come up with your key points, start with the left interval value, right? So that's going to be, the first point is going to be 0. Then keep adding in increments of 3/2 pi. So what will our next value then naturally be? Okay, so we're actually going to write these guys as ordered pairs, and we'll talk about their y values in a minute. So 3 pi halves will be our next point. What will be the one after that? So remember, the idea is you will keep adding 3 pi halves to each of your new x value, right? So that means when we had 0 as our leftmost point, to get the second point, we took 0 and added 3 pi halves to that. So for our third key point, we will be taking the 3 pi halves and adding another 3 pi halves to that. So what did you guys say that came out to be? Yeah, 3 pi, because you're going to end up with a total of 6 pi halves, which will be 3 pi. So that's going to be our third point. And then for our 4th point, you're going to be taking 3 pi and adding another 3 pi halves to that. So what will that give us? 9 pi over 2, very good. And then what will that 5th point be? You should end back at the 6 pi, which is the end of our period, right? So that's going to be, again, just as a math calculation, that would be your 9 pi halves. And then again, add 3 pi halves to that, which of course comes out to be 12 pi halves, which is 6 pi. Okay. Now, once you have figured out your 5 key values for the x coordinates, how are you going to find those y coordinates? You've got your x value, right? So technically, you should be able to put it back into your function and calculate the y. So think about it. If we do cosine of x is 0, 0 over 3, that will become what? Cosine of 0. And what is the value of cosine of 0? Yeah, because that's the starting point, right, on our unit circle. If you think about it, so you are actually going to be at 1. We're working on example 3. Now, do you know if this is going to be the maximum point, minimum point, or the intercept for this function? Maximum, and we know that because our amplitude we said was 1, right? So if we know the amplitude is 1, then positive 1 will become the maximum and negative 1 will become the minimum point, right? So this guy here is actually going to be our maximum point. Okay, now when you put 3 pi halves for x, what will you end up getting here? Yeah, you're going to get 0 because you are looking at 3 pi halves divided by 3, which will be pi halves, right? And cosine of pi halves puts you at 90 degrees, which would be 0. And what will this point be? In terms of maximum, minimum, or intercept? It's going to be our intercept. Very good. So naturally, that means our next point should be what? Negative 1, yeah, because you're going to be at a minimum. Remember, we talked about this last time. These points go in a cyclic manner, right? Because you're going to have maximum, intercept, minimum. What should be the next? You should be back at an intercept. Very good. So at intercept, you will be at 0. And then when you go back up to a maximum, where will you be at? At positive 1 again. So remember, to find the y values, you can always plug these x values that we calculated back into the original function that you started out with. So just replace your x with these x coordinates from your ordered pair. Or you can use the idea of the point going from maximum to intercept to minimum to intercept to maximum, and that will also help you come up with your ordered pairs. All right, so what is this graph going to end up looking like? Okay, so remember, we are going from 0 to 6 pi. Yeah. So we're going to have a longer x-axis on the positive side. And then we are going from 0 to 3 pi halves. I'm actually going to break this down into pi halves, pi, 3 pi halves, 2 pi. And then let me see, 5 pi halves, 3 pi, 7 pi halves, 4 pi, 9 pi halves, 5 pi, 11 pi halves, and 6 pi. If you want to break it out further with just the 5 point, you can do it that way also. Okay, so and again, just for comparison, I'm going to show you with the basic cosine function, and that's our amplitude of +1 and -1. Okay, so this is kind of what the cosine function would look like with a period of 2 pi, right? Now, to show you that horizontal stretch, you will notice when we start graphing these points, we're at 0, 1, so that's the same starting point, but now our x-intercept is at 3 pi halves, so right here. And then we've got minimum at 3 pi, x-intercept at 9 pi halves, and maximum at 6 pi. So you're looking at stretch, which would end up looking like this. And in the red, we have y equals cosine of x over 3. So as far as domain and range goes, what are we noticing here compared to that y equals cosine of x function? Did this horizontal stretch change any of that? No, because you would still be looking at all real numbers for your domain, right, for both functions, because it's still going to use up all your x-axis values. And then what's your range for these functions? Yeah, so your range would be going from -1 to +1, because again, our amplitude didn't change, right? Amplitude still stayed at 1, so that function really is not changing. All right, anybody have questions on the process? The graphing is obviously not the hard part. It's coming up with your, what's the amplitude, how does the value of b affect the period of your function, and then breaking that period interval down into those 5 key points. So any questions on that part? Especially since you were not here last time. You kind of got it? Okay. Adrian? All righty, so let's go back here. Okay, so now talking in terms of translations, let's see what happens when we bring another variable in, the constant c. And as you can see, so far we have looked at what happens when you have an a in there, which is the amplitude, b, which changes our period, but now we're bringing the c value in. So again, with both sine and cosine functions, they're saying this will result in horizontal translations for shifts. So they're saying, okay, if we compare our graphs with just a, y equals a times sine of bx, and what happens when you compare that with y equals a times sine of bx minus c. So basically we are saying one cycle of our function is actually going to be completed when you take this parentheses part, the bx minus c, set it equal to 0. 2, when you take bx minus c equal to 2 pi, because again, remember, sine and cosine functions, the original period for these functions is 2 pi. So you're basically saying, okay, if we start at the starting point of 0 and go up to 2 pi, how will these values of b and c actually affect your horizontal shift? So your endpoint for your interval is actually going to end up becoming C over B, which is coming from this first equation of bx minus c equals 0. You're basically solving it for x. And then your right endpoint is coming from this equation, bx minus c equals 2 pi, where again, you're solving this for x. So once you solve these for x, your x values are going to be between these two values. So in this case, they are telling us that your function will have a period, obviously still the same thing, 2 pi over b, but now you're actually going to have a phase shift based on that value of c over b, because you can see that c over b is changing both our endpoints, right? Because we are adding it to that period of 2 pi over b right here when we have that phase shift. All right, so now looking at how does the amplitude, the b, and or in this case, the phase shift is going to affect what our graph is going to end up looking like. So you can just kind of look through that definition here, but this is something you're going to need to obviously keep track of, is now we need to figure out what that phase shift is going to be based on these two equations. So looking at our example 4 over here, you have y equals 1/2 sine of x minus pi over 3. 1/2, of course, is the amplitude. What's our b value in this case? Just 1, yeah, because that's the coefficient on the x variable, so that's just 1, which means your period actually is not going to change, because 2 pi divided by 1 will still give you 2 pi, and then of course your c coordinate is pi over 3. So again, using those equations of bx minus c equal to 0 and bx minus c equal to 2 pi, go ahead and solve each of those equations. You're getting x equals pi over 3 and x equals 7 pi over 3. So that's now going to be our interval. Again, remember, you take your interval, subtract the two values, and then you divide it by 4 to come up with your 5 key points. And so what happens when you subtract 7 pi over 3 minus pi over 3? What does that give you? 2 pi, right? Because it's going to be basically what, 6 pi over 3 when you do that subtraction? Yeah? And then 2 pi divided by 4? Because remember, we always break our interval into 4 equal parts. Yeah, pi half. So now you're starting with your left endpoint, pi over 3, and then for each of these, you're adding pi halves to it to get the key points, okay? And, you know, I guess I didn't include the graph for this, but if you look at the graph for it, they're actually using a graphing calculator to do this graph, and that's the reason why I didn't include it in there, but just to show you quickly what happens with that phase shift. Okay. So I just talked to the IT people that everything was working fine, and now my graph is not coming up. Okay, we'll wait for it to come up. Till then, let's get on with our example here. So we're not graphing in these, right? We're just analyzing. So we want to know what the amplitude is, what the B and the C coordinate constants are, and then based on that, how does that change our period interval, and how does that change our key points? So go ahead and identify your A, B, and C constants in this example for number 4. Doesn't look like it's going to show up on this one, is it? Nope. Okay, so what do you got for number 4? Okay. And what's the b value here? It will be 1. And your c coordinate. Actually, it's just going to be pi over 2 because the minus is part of your definition. Okay. So obviously the a tells you the amplitude, right? So amplitude, of course, will be 2. What's the period going to be for this function? 2 pi, yeah, because you always take 2 pi finally, right? All right, very good. 2 pi divided by b, which will, of course, be just 2 pi. Okay, and then let's solve those equations. So remember, you take bx minus c, set it equal to 0, and you take bx minus c equal to 2 pi. So of course, for us, b is 1, and c is pi halves. And what do your 2x values come out to be? Okay, pi over 2 from here. And you said 5 pi over 2? Yeah, because you're going to end up with 4 pi plus pi, right? Say that one more time. C only, yeah, because remember your b is just 1, right? So this guy would be 1x, which is just x, and then you're just substituting for c. Now, if your b was something other than 1, then it would make a difference. But since b is 1, it didn't affect our equation. All right, so this guy will become 4 pi. What is wrong with you? Nope. Not sure why you're doing that. Okay, so that will become your interval then, which will go from pi halves to 5 pi halves, taking our 2x values that we just calculated. What's the difference again between those two numbers? It will be, again, 2 pi, yeah, because you're going to do 5 pi halves minus pi halves, which is 4 pi halves or 2 pi. And then remember, you break it up into 4 equal parts. Then you take that 2 pi, divide by 4, and again, what do we get? Oh, very good, pi over 2. So now for our key points, remember, start from the left interval, leftmost endpoint. So for our first ordered pair, we would be starting at pi halves. And then you keep adding this value, right? The pi halves we just calculated. So what will our second ordered pair look like? Or x value for the second ordered pair look like? Yeah, because you're going to be adding pi halves with pi halves, which is going to add up to pi. Okay, your next x value will be 3 pi halves. Very good, because you will be adding pi with pi halves. Okay, the fourth ordered pair, 3 pi halves plus pi halves will be 2 pi. Very nice. And the last one, our fifth point. Ouch. Very good, yeah. Okay, 5 pi over 2. And then your corresponding y values for all of them. Two. And so that's going to be your maximum point for pi halves. Again, remember what I told you. When in doubt, go back to your original function and you're replacing x with the ordered pair, right? So this is going to be pi halves. Of course, pi halves minus pi halves is 0. Cosine of 0, again, is the starting point of our unit circle, which will be 1. Yeah, so 2 times 1 is going to be 2. So this guy is actually going to be our maximum point. Okay, so if this guy is maximum, what's our next point? Intercept, yeah, very good. Your next point is going to be intercept, and which means your y value is going to be 0. So maximum intercept, what's the next point? Minimum, which is -2. And remember, these 2 and -2 values are coming from your amplitude. Because if the amplitude of the function is 2, that means your highest value, you can go as far high on the y-axis is 2, and as far low as -2. So what's our next point now? Intercept. Which again means y is going to be 0, and the last point. Yeah, maximum and +2. Very good. Oh, there's something not working on that corner. Okay, so as far as analyzing goes, that's all they're asking you to do is find those ABC values, get your amplitude period. Okay, so take this value of pi halves and put it back into the original equation.
So is that after you divide by 4?
No, just this original equation. So we divided by 4 to figure out in what increments these points would be separated, right? So this pi halves is telling us start with the left end point, whoa, and then keep adding pi halves to it.
Yeah.
So are you okay with how we came up with the x values?
Yeah.
Okay, so the y value, I am actually taking my original function, which was this guy, and then I am replacing my x with these ordered pairs. So let's start with the first one. That's going to be pi halves minus pi halves, right? So we're subtracting the same number, will give you 0. Now remember cosine of 0, and here you can actually use your calculator if you want, is going to be 1, and then 2 times 1 gives you 2. So that's how we got that first ordered pair. So if we repeat that process with 2 times cosine of, this time our second ordered pair is pi. So you do pi minus, yeah, you're literally taking all of these x values and putting it for the x in your function. So what is pi halves minus pi halves? will again be pi halves. So remember again, pi halves is the 90-degree position, right, on your unit circle. That means your cosine value is 0. So 2 times 0 will become 0. And then with 3 pi halves, you're going to now put 3 pi halves for your x. And what is 3 pi halves minus pi halves? Pi, so cosine of pi would be at the 180-degree position. So what's your cosine value for that point? 180 degree is the negative x-axis. So what's the cosine value at that point? -1. So that will then end up becoming -2. Do you see that?
Yeah, yeah.
All right, and that's the same thing that's going to happen with the 2 pi and 5 pi. But the idea that we are using, if you remember, when we had done, I think it was example 2, we had talked about how these guys alternate, right? You go from maximum to intercept to minimum, intercept, and maximum. So no matter what cosine or sine function you're looking at, they're all going to follow this pattern, right? The only difference is a sine function starts at what point? It starts at 0, 0, right? So it actually starts at an intercept, whereas a cosine function starts at the maximum point. So this number 2 is that same value that we have for our amplitude. So amplitude tells you how far on the y-axis you're going to go on the positive side and how far below you're going to go on the y-axis on the negative side. So we know for the maximum point, you're not going to go beyond that amplitude number. You are going to be at 2, which means at the minimum point, you're going to be at -2. So your maximum and minimum y coordinates will always go from 2 to -2. And then all the points that are intercepts, because that's where you're crossing the x-axis, all of these y values are going to be 0 for the intercept. So you can do the calculation like I showed you, or you can use that idea of, I'm going to be at a maximum here, I'm going to be at an intercept here, and a minimum here, and that can also help you. Okay. Does anybody else have questions on this? Are we okay? Adrian, you okay?
Yeah.
Yeah? All right, wonderful. Okay, so that's basically what they're asking us to do when they say analyze the graph. Now we're getting into the actual sketching of these graphs. So just to go over this example here, you're looking at y equals -3 cosine of 2 pi x plus 4 pi. So again, your amplitude is, again, remember we take absolute value, right? So amplitude will be +3. Period is going to be 2 pi, and then of course your b value is going to be that coefficient on the x, which is also 2 pi. So 2 pi divided by 2 pi gives you 1. So period actually is going to shrink in this case, right? Because you're only going from 0 to 1 now in your period. And of course, solving your equation, you take the 2 pi x plus 4 pi and set it equal to 0 for the first part and set it equal to 2 pi for the second part, and that will actually give you your interval for your period. Remember, it's still 1, right? Because think about it, the difference between the 2 points is still 1. So going from -2 to -1, again, subtract those two values, divide it into 4 equal parts, and then come up with your ordered pairs for the 5 key points. And then, of course, once you have those ordered pairs, so look at that, an amplitude of 3, so you can see how high up those waves are going, but then period is only a period of 1. So you can see we are literally staying between these points right here, between -2 and -1. I mean, that's your period for the function, so it really shrinks up because it's such a small number. Okay, so we're going to try and replicate that for our example here. Again, start by identifying your A, B, and C values. So for number 5, what will those values be? A is 1/2, very good. Very good, yeah, exactly. And this time it's a sine function. So typically it starts at the x-intercept, right? At 0, 0. But now we're going to have to see what the interval for our function is going to be. So where we're going to start. So that's where we need to go ahead and calculate those equations. All right, so your amplitude is only going to be positive 1/2. What's the period for this function? 2 pi divided by b, right?
Oh, shoot.
You switched it? Oh, okay. All right, let's be careful. So yeah, you're dividing by b. So what will that give you then? Just 2. Very good. Yeah, so you're actually going to have just a period of 2. And then let's solve our equations, which will be taking pi times x plus pi, set that equal to 0. For the second part, pi times x plus pi equals 2 pi. So you always set those equal to 0 and 2 pi. So go ahead, solve those and tell me what your x value should come out to be.
Is it pi x plus pi equals the 0?
Yeah, so it's whatever you have in that parentheses after your function sine or cosine.
Okay.
So yeah, whatever you have in here is what you're setting equal to 0 and equal to 2 pi. In this case, your c is actually a negative value. Yeah, so c itself is a negative number. Let me fix that. Technically, c is negative pi then. Yeah, because of the bx minus c. Yeah. So what are we getting for our x values here? Very good. What did you say?
M1.
Positive 1? Okay, let's take a look here. Start by moving that pi by itself. And then, of course, you've got 2 pi minus pi, which will just give you pi. And when you divide both sides by pi, you'll get positive 1. Okay, very good. So that's going to be our interval, which will go from -1 to 1. Okay, so let's go ahead and subtract those. What do we get? So remember, you do 1 minus -1 will be positive 2. And then you take your positive 2 divided into 4 equal parts. Okay, so that means our points are going to be in the increment of half, right? So start with your leftmost endpoint, which will be -1. So what should our next x value be from here? -1/2, because remember you're just adding half, right, to these numbers. So you're taking -1 and adding 1/2 to it, which will just give you -halves. And then you're taking -half and adding that positive 1/2 to it, which will give you 0. Very good. So you're actually not going to see pi in your x values for this interval. Then you're taking, of course, 0 and adding 1/2 to it. And then our final point. Yeah, you should end up at that right endpoint, right? So you begin with the left endpoint, keep adding those increments of half, and then finally, if we did this correctly, our last key point should be the right endpoint. Okay, now what is going to be our corresponding y value here? So for the first one, I am actually going to use my equation. That's -1/2 sine of pi times x, and in this case, our x is -1 plus pi. What will that give us? 0. Okay, so this will actually become -pi and +pi, which will end up canceling each other out. So you're looking at sine of 0, which is again the starting point on your unit circle, right? And at that point, you do have 0 as your sine value. So this is actually what point? Maximum, minimum, intercept? This will be an intercept, and that's always where a sine function begins. What should be the next one? Will it be a minimum or a maximum? Minimum, what do we get for that point? Yeah, -1/2. So all you're going to be doing is replacing that x with -1/2, which will end up giving you -1/2 pi plus pi, which will be -1/2 sine of pi halves. Sine of pi halves is 1. You end up getting -1/2, which will be a minimum. So we started out with the intercept. We ended up at the minimum. What should our next point be? Yeah, so we will be going back to an intercept for the third point, which means we will be at what? Y? 0, 0, yeah. Okay, so you've done intercept, you've got minimum, we're back to an intercept. What should be our next point? You will be at a maximum, and maximum means y value is going to be +1/2, and my last point. Yeah, because you are back at an intercept, so this will be a 0. Okay, they are actually asking us to graph this guy. Let me see if it will let me. No. No, it doesn't let me do that. Okay. So again, we're starting at -1 and going to +1. Okay, so let me see, we will be at 0, 0. We will be at 1/2, +1, -1/2, -1. And our amplitude was 1/2. Okay, so you're starting out at the intercept at -1, 0. You've got minimum at -1/2, -1/2. We're back to an intercept at 0, 0. Maximum at 1/2, 1/2, and then intercept again at 1, 0. Now, if they asked you to do a couple different periods, what would you do? How would you expand this graph? Yeah, so what should our next x value be here? No, 1.5, right? Yeah, 3 over 2, you'll be at a 2, 2.5, 3, right? So at this point, we are at a maximum and then we ended at an intercept. So what should be our next point? Minimum. Yeah, so you would be going down here, then intercept, going up and intercept, right? You're basically just making one another basically cycle of what you just did, and same thing on the negative side if they ask you to go on the negative side. So just keep in mind that even though we are only graphing for what is within our interval, they can actually ask you to expand this to a couple different intervals on both sides of your graph. So when you're working through your homework, just kind of be mindful that they may not only want that one period that we're doing. They may want you to do this for a couple different rounds. Okay, so let me just kind of quickly recap this. We have our amplitude, which tells us our maximum and minimum values for the y coordinate. We calculate our period, so that tells us, you know, how far our points need to go. Using the bx minus c part of the equation, you set it equal to 0 and 2 pi, and get your 2x values, which actually tells you the interval that we will be graphing in. We always take the right-hand side value and subtract the left-hand side value from it, right, to get your distance between the 2 points. And then we always divide them into 4 equal parts. So it tells us in what increments we will be doing our key points. Start with the leftmost value from the interval, and then keep adding this 1/2 till you get to the rightmost point, right, which should give you your 5 equal points. And then using those points, you are going to calculate your y coordinate, and then of course graph your function. Okay.
You said c was negative pi, right?
Yeah, if you just want the value of c itself, because you have a plus sign here. Yeah. So remember, by default, our function is bx minus c. So that actually means that c itself has to be a negative number, and the 2 negatives is what's making this into a positive sign. Yeah? But you know, of course, if you go through the calculation here with the equations, it really doesn't matter if you have a positive or negative sign, because when you solve the equation, you'll automatically see what your signs come out to be for each one. Yeah. Any other questions? No? Did you guys have any questions? No? Okay. Okay, so of course that last variable that we want to talk about is the constant d. So we looked at a, b, c. This is our last one. So this one will actually be either added or subtracted to the rest of the equation that we saw. So this will end up being y equals d plus a times sine of bx minus c, or same thing with the cosine function. And that d value is actually now going to tell you what your vertical translations are going to look like. So in this case, if d happens to be a positive value, your graph will of course shift up. If d is a negative value, your graph will of course shift down. So this is kind of like the vertical translations we had seen in college algebra, right? Now this is kind of interesting. So they're saying, in other words, the graph oscillates about the horizontal line y equals d instead of the x-axis, because you know, if you're moving your graph by d units up or by d units down, then that horizontal axis will now be at y equals d instead of being at the x-axis, which means your intercepts are not going to be at the x-axis anymore because of these vertical translations. You will still have your maximum and minimum point, but that will be again with respect to what that d coordinate is going to be. So looking through this example here, you've got y equals 2 plus 3 times cosine 2x. So what is this d representing? 2 representing again. So that's your d value, right? And it's a positive number, which means our graph is going up. The 3 is the amplitude, and 2 is your b coordinate. Okay? So in this case, your amplitude is 3, but now it's actually with respect to this line, y equals 2. So you can see I have my maximum point actually at 0, 5 now. My intercept, which technically would have been on the x-axis, is now at this value of 2. My minimum point is at -1. Again, my intercept technically, and then again, my maximum point. So now you can see our amplitude is 3 being added or subtracted with this value of 2. So 2 plus 3 is 5. That gives you your maximum points. 2 minus 3 is -1, which gives you the minimum point, and then that 2 itself is what we would consider as our intercepts. So look at how this graph looks like then. So your minimum at -1, maximum at 5, and now this becomes your horizontal axis at y equals 2, which is what I'm calling as our intercepts. Okay. And then of course your period is pi, because you would take 2 pi divided by 2, which would give you the period of pi. All right, so go ahead, identify what variables you can in number 6, and then let's see how that's going to change our graph. So what's our A coordinate here? 2, B, 1, C. There is actually no C, because it would have to be in parentheses with bx minus c. So what is that -5 then? That is actually your D coordinate, yeah, which is -5. All righty. Okay, so obviously the A value tells us the amplitude, which is going to be 2. What is going to be the period for this function? Yeah, very good. Since we don't really have a C value in this case, we don't have to worry about doing those equations bx minus c equal to 0 and equal to 2 pi, which means our interval is actually going to go from 0 to 2 pi, okay? Now, if we were just doing this, let's say without that vertical shift of -5, we were just doing this as the basic, what is this? Cosine function. You would take this interval, right? Divide it into 4 equal parts. So that would be 2 pi minus 0, which is of course 2 pi. Divide that 4 equal parts, and what do you get? Yeah, you'd get pi over 2. So for the original cosine of x function, what would be our ordered pairs? We would start at the left endpoint. What would be our next point? Pi over 2, very good. The one after that? Pi. Okay, next one. 3 pi over 2, and the last one. You would be back at 2 pi, very good. And what would be your y coordinates for the cosine of x function? Say that one more time. Because you're using the amplitude, right? And in this case, you would be at, hold on a second. Our amplitude is 2. Where are you getting -3 from? Are you doing the original, the function that's given to you? Okay, I'm actually talking just in terms of if you had without the vertical translation. So technically, I'm looking at the function just 2 times cosine of x. Because I want to actually show you how that translation happens. That would be 2, right? For the amplitude, yeah. So that means where would we be at for pi halves? Okay, so we're basically starting at a maximum point here, aren't we? So what should my next point be? The intercept, which means I would be at what? Okay, then my next point? -2 for the minimum. Very good. And my last one. Okay, so if this was without that vertical translation, how will this reflect when you bring in that -5? Because your x value will still be the same. Yeah, you're just subtracting 5, exactly. And that's just what I wanted to show you here with the graph. From each of these y values, you start subtracting 5, and you're going to get your ordered pairs for the actual function. So what is this value going to be? Very good. Okay. That's okay. -5, okay. Adrian Flores, what will be our next ordered pair? Okay, Sydney. -5, yeah. And Adrian will do you again. Medina. Okay, so this is where, again, you should see those maximum, minimum, and intercept values are all going to be at the same x coordinate. But now you will be at a maximum at -3, which is what you should notice again here on this maximum point. For a minimum, you're at -7. And then since we moved by a distance of 5, your intercepts are now going to be in line with that y equals -5. And then our graph, since we're going down to -7 as our lowest point, we're going to need a longer y-axis. And maybe our x-axis somewhere over here. So let's see, +1, +2, -1, -2. And then we are doing this in increments from 0 to pi halves, pi, 3 pi halves, and 2 pi. And then, of course, you can increase that for more periods. And I'm actually doing the 2 times cosine of x function just to show you as a comparison. You guys can graph the final function if you like. I'm probably not going to be in line since I'm really just guessing where I'm graphing these. But something like that is what you should be seeing when you graph your function. And then again, if they ask you to do periods with this, you should be able to translate it on the right and left of your graph. Yeah, but that's basically what I'm trying to see. Yeah. Alrighty. And these kind of graphs I have noticed actually work a lot better if you have a grid instead of trying to do this freehand, because I know my points are not going to be in line with my X and Y coordinates just because they are so much roughly sketched out. So what do you think? Of course, we know the domain is still all real numbers, but for this function, y equals 2 times cosine of x minus 5, what is its range going to be? Okay, just reverse the order of your numbers, right? Because we put the smaller number first. So -7 to -3 is going to be the range of these numbers. Okay, so obviously doing that 2 times cosine of x, you can see that shift of the 5 units. And then remember what I was telling you with y equals -5, that now becomes that horizontal axis for your graph. All right, did anybody have questions on this example? Yeah, go ahead.
There's no C, just 0 and 3.
No, because 0 technically means it's still a number, right? Which in this case, I guess it really wouldn't matter, but the only thing is you don't have that phase shift, right? Which means your graph actually hasn't moved horizontally in this case. So when you don't have that C value, that's why we were able to just take our 2 times cosine of x function and just move it down, right? But if you had a C value, then that would affect if your graph moved to the right or left also, which would definitely then mean that if this was my function, it would be going down, but then it would probably also be moving left or right, depending on what that C value was, because that's what happened in this previous example. We didn't really draw the original function, but here, of course, your graph, because we had what, plus pi, so that actually means your graph moved to the left by pi units. Because typically, where would our graph have started? On a sine function. Sine starts at 0, 0. Normally, we go from 0 to 2 pi, right? And what was our interval for this guy? We were at -1. So you can see even that shows you that we have a shift in our graph. So that's what would have happened with this guy if you had a C value. Okay? Because I guess you could think of C as being 0 because it's not going to affect our calculation in this case. Alrighty, so the last one is actually just trying to see where we can use these examples. So this is just modeling based on our trig function here. So they're telling us this table here is showing the depths of the water, and this is in feet, at the end of the dock every 2 hours from midnight to noon, and t equals 0 is basically starting at midnight. So that means at midnight, we're looking at a depth of about 3.4 feet. At 2 a.m., it's 8.7. So by the time you get to noon, that depth of the water is just at 1.2 feet. You can see at 10 in the morning, it's at 0.1 feet. So they're saying, okay, use a trigonometric function to model the data. They want to know then based on that function, can you say what the depths would be at 9 a.m. and 3 a.m. because obviously these guys are recording every 2 hours, right? So we're getting all the even hours. And then they want to know if a boat needs at least 10 feet of water to moor at the dock, then at what time would they be able to safely dock the boat at? So in this example, they're actually using the idea of let's find our A, B, C, and D values if we can, and then based on that, we can put it into our sine or cosine function and then come up with the model. And in this case, they're actually going with the cosine function. So the idea is if we can find these A, B, C, and D values, we can come up with our function here. So they're using the idea of what's the maximum and the minimum depth that was given to us. And then basically the amplitude will be twice that, right? Because if you're talking about the amplitude, think about the example we just did where we had an amplitude of 2 in that case, right? So we were going from what, -7 to -3 on our y values. So that's going to be double of that amplitude distance, right? Because we're calculating amplitude from your horizontal axis. So they're using that same idea of the amplitude being twice what your maximum and minimum would be. So that's why we're taking the A value to be 1/2 of maximum and minimum using your table. The maximum was at 11.3, which was happening at what time? 4 a.m. And then the minimum was at 10 a.m. at 0.1. So take that difference, divide by 2, and you get your A value, which we can go ahead and then plug into our cosine function. Now the idea is figuring out the other points. So they're telling us if you're looking at the cosine function, we know it completes a period when it goes from the maximum to the minimum. So they're actually using the time now, the x value in a way, and that's going to be minimum at 10 a.m., maximum at 4 a.m., multiply that by 2, which will give you your period. And then of course, remember the period function was 2 pi divided by b. They're rewriting that as b equals 2 pi divided by the period, and that's actually giving you an approximate b value of 0.524. We can use the phase shift calculation to come up with our c value, which in this case, they're telling us the maximum depth occurs at 4 hours after midnight. So that can be your left endpoint. Using that, they're calculating what the value of c would be, which is coming out to be 2.096. And then of course, using again that calculation of the minimum and the maximum depth, taking its half to calculate your d. So all of these values you can see are basically based on what our maximum and minimum function values would be, at what times they are occurring, and then we are using all of those values to plug into our cosine function. And once you have the model, coming up with that second part of the problem, which was asking you what the depths would be at 9 a.m. and 3 p.m. 9 a.m. is 9 hours after midnight, so t would be 9. 3 a.m. of course is 12 plus 3, right? 15 hours after midnight. So that's going to be t, or your x coordinate, whatever you want to look at it as. You can plug that into your function, and come up with the depth of your water. And the C part was actually asking you to, during what times would it be safe to dock? So they're actually using a graphing calculator to help you out here. And they're saying, they said we need a minimum of 10 feet of water. So where does the 10 feet of water happen? And of course, it's happening between 14.7 and 17.3, which comes out to be approximately from 2:42 to 5:18 p.m. So we're actually not going to be doing that part since we're not using graphing calculators here. What I would like you guys to do is just come up with the sine model. So they're showing you the cosine example in the example 7 for exercise 7. I'd like you guys to work on that and show me what you have next time. So work on the sine model. A lot of your calculations are going to be the same, okay? Because that maximum minimum value is not going to change for this example. So just let me see what you guys come up with. So we'll talk about example 7 and we're done with 1.5. So also work on number 7, but prepare for a quiz also for section 1.5 for Thursday. Yeah, and then we'll do the quiz. We'll look at the answer for 7, and then we'll start with 1.6. Okay?